This. So we will try to understand why we need Hadoop. Can't we solve the problems using existing systems? Do we really need a Hadoop or some big data technologies? Okay. So before getting into that, so we need to understand what we are doing with the data. Whatever the data we are collecting, whatever the data we have stored, whatever the data we have collect from the different sources, what we are really doing with that? Any idea? We're doing analytics, correct?
Right.
So what is analytics? What is
Analyzing the data,
analyzing the data? Okay. So what we're getting at the end after analyzing?
like achieving to a particular requirement, like what is required to be achieved from that data. What is
Okay.
analyzing that way?
Okay.
I don't know.
So
Hmm.
yeah, we're collecting the whole. We're collecting the data. We're going and we are taking the data and we're processing it and we're getting some analytics. So analytics are like some I can say after processing the data, what you'll get some results in the form of numbers, like which will help to improve our business. It will help to improve our where we stand in the market. It will help us to like is there any improvement we can do in our product, right? So that is called analyzing our data. It can be past data, it can be present data, to get a better results. I mean, I can say to produce a better results, or we can say to start a good business or better. I mean, I can say improvement in that, right? We're actually what we're doing. We're doing analytics, analyzing the data. So till date, how we are doing that? So till these days, we are not having a Hadoop, right? How we were doing that? That we were doing using, we were doing using,
RDMS,
yes, we'll call it,
RDBMS
yeah,
only.
we will call it as an existing system or traditional system. We will call that as a traditional system. So using RDBMS, we used to do that, right? So how it has,
Hmm.
let's have a little look. I mean, how it is working in the traditional system. Then why we need Hadoop? Okay, here there are different sources from where we'll collect the data, correct? There are different places. So it doesn't mean that all projects has to include all the sources. It's a, totally depends on the project to project. Some people may be collecting from the data from the financial institutes like the stock market. Some people are collecting the data like from satellites or some of the sensors. Some people are collecting the data from the social media like Twitter, Facebook, or whatever the LinkedIn, wherever they are. Or some people are collecting the data from the CRM or ERP applications for the further processing, right? Or it can be any mobile, or it can be any device. It can be any your I can say smart device who actually emits the data, right? So what we are doing, we are collecting the data from those sources, right? We'll collect the
Right.
data from those sources.
Hmm.
After collecting the data, what we will do? We have to process this data, correct? Since it is a raw data, right? It is directly coming from the sources. The data may come as a duplicate. The data may has a binary format. The data has the data may not be contain the accurate results, but the data will contain the results what we want. Along with that, the data will contain the unnecessary details as well. Correct?
Yes.
This raw data, by using this raw data, I cannot directly generate a, reports, or by using this raw data, I cannot really get the reports, or I cannot really get the analytics out of it. So I need to do some process this data. I need to take through them some process. The process will call as the ETL process. The process will call ETL process. So to do this process, we already have a ready-made tools like Informatica, like we have Ab initio, like we have a Talent, like we have. There are so many tools are available for that, right? Which are licensed. We need to remember that which are licensed. No, no, there are no much open source for ETL. What is ETL here? Extract the valuable information from the raw data. How will I extract? By applying some transformations. By applying some transformations. Apply some transformations and extract the valuable data, required data, and load into a storage. Load into a storage. Load into a storage. The storage will call
Mm-hmm.
as a data warehousing system. These are the storage servers, guys. These are not processing servers. These are storage servers. Like in this a storage cluster, or it can be your data warehousing system. So before loading into this, there are so many things like normalization and all those things will apply, and we've load the data into this. Why we are loading the data into data warehousing system? The form of tables for easy to access. If it is data in the form of tables, it's easy to access, it's easy to retrieve, it's easy to query, too easy to do that. So if I want to, once the data is available in the data warehousing system, if I want to do any processing on that to get the analytics reports, I should have a different processing system who actually generate the reports. Those reports can be making use by business analysts, business users, DW administrators, so many other people who actually look into the data to process it, right? So this is how an existing system works, very high level. This is how an existing system is working, right? So this system is well and good, looks simple, it's working very fine with an existing data, right? But we are in 2017, 2010, I mean 2017, I can say. So where we are getting huge amount of the data. So let's see the problems are associated with this system once the data is grown. Look at here, my data is getting growing. If the data grows, I need to go with the better ETL tools. Yes or no? I need to go and buy a
Yeah,
more
yeah, yes.
licenses. I need to buy more licenses for this.
Right.
And okay, I have bought some licenses. I have implemented data and all those things. Now I need to go ahead and increase my storage part as well. So initially it was loading only 1 TB. Now I'm loading 10 TB. So I need to improve my storage part as well. So the improvement is here. Scale up. It is called scale up approach. Scale up means we have to go with the bigger missions. We have to increase in the upper towards upperwards. 1 second, please be
Mm-hmm.
online. 1 second, please be online. Yes, Srinivas. Yeah. So here also I need to invest some amount of money for the cost. Okay, fine. I have invested money, no problem with that. So once the data is available here, this is my processing system. So data is available in the different servers, and my processing is in the different servers to handle a huge amount of the data here. Since my data is grown, my processing system, I should have a better RAM. I should have a better processes. I should have a better processor to process the data, to generate the data. I mean, to generate the reports in given time. I mean, it means a very less amount of the time. So when the data is increased, I should go with the better processors to achieve the I mean, I can say to generate the reports in the less time, to get the analytics in the less time, right? So if you look at this old architecture, I have a storage differently, I have processing differently, where my data has to come to, if I want to process any data, my data has to come from the data warehousing system to my processing system. It has to traverse through a network, and the data has to be processed here. So where is the data is going towards your processing system? This is called code locality. Code. Wherever your code is there, wherever your code is there, your code will be running here on server. Your server will go and connect to database and it will get the data for the generating reports. That's called code locality. So since the code locality is is the only one option in the traditional approach, so the data has to travel through a network. Let's say I want to transfer 100 GB data. I want to process 100 GB data for some reason. Last 30 days, I want to see. I want to generate some reports for last 30 days. How the data is. I mean, how my business is performing. So I have to process 100 GB data for last 30 days. So last 30 days, 100 GB data has to be transferred through the network. To transfer this network, let's assume that you have taken 1 minute of time or 2 minutes of time. And processing this data again, you may take 2 more minutes of time. Total 4 minutes is taken to generate a report. So you have opened a web page and you're trying to look at the something. Let me show a simple example how the reports will be generated, guys. That will gives you an idea. Let's look at this. I'm going to show you a simple example. Okay. So this is my channel. I want to understand. I want to understand how my channel is performing. So how my channel is performing, I just want to understand. So for we have here something called analytics. Okay, this is the analytics. You'll be having some side also. You'll be having something called analytics. Click on here. Yeah, look at the analytics. When I click on this analytics, I'm getting the report, watch time and average view duration, views, and how many likes, how many dislikes, and how many comments, how many shares. All the information is coming. All the information is coming, right? This is called analytics. So by seeing this, I can understand, okay, this is what happening here. By seeing my comments, I can go ahead and, okay, this is what the people are expecting. But I can see this. This is the report is for last 28 days. The report is for last 28 days, right? So if I want for last 1 year or last 2 years, or I mean I want my. So when I select the day, let's say let's assume that uh, last 90 days I'm selecting. If to generate this report, if it is taking 4 minutes of time, if it takes the 4 minutes of time, shall I mean, will I wait on this web page or will I wait on here to see the report? I will not wait, right?
No.
I want the report like quickly, like
Yeah.
within 5 seconds, 3 seconds, 4 seconds. I want the report like that. Yes or no? Right? So our clients are expecting such kind of thing. So if to download the data, process the data, and all it is taking the 4 minutes of time, really no one will be interested on our product. Correct? By the time we generate the report, our competitor will launch. He will analyze his data. He will launch a new product, and he will start campaigning his product. Correct? So why this problem is happening? Since I have to download, the download itself is taking 2 minutes of time. Cursor. Yeah, the download itself is taking the 2 minutes of time. If I avoid the downloading part, so wherever my data is there, if I go on process here, if I go on process here itself, I don't need to download. My logic I have written, send your logic to the storage part and start processing here only. I'll avoid 2 minutes of time. I'll save 2 minutes of time. Okay, it means the old system is time consuming process. Why time consuming process? No parallel process.
Veera, can you come again? I couldn't able to get that. The again, you are saving 2 minutes of time. You are saying that logic I couldn't able to understand.
Okay.
From processing, you are again going to the storage, and you are saving 2 minutes. Come again that point alone.
Yeah. So instead of
Hmm.
downloading the data, you don't download. You have written your logic. That will be the data where there only. You have written your logic. Let's say your logic is 100 MB. Whole your project or whatever it is, 100 MB. Okay. Instead of downloading the data, upload your 100 MB to the data wherever the data is there, and ask that servers to process there only. Ask those servers to process there only. It means I should have a storage and process servers here. Both should be there. Understand what I'm trying to say?
Yeah, but that is only storage, right? You are adding the processing in the data warehouse itself. That's what you are trying to say now, right?
Not existing. I mean, I'm showing you a drawback here. Okay. So that part,
Mm-hmm.
the data storage and process will be together. That we are going to see in Hadoop.
Okay. Okay,
Okay.
okay, okay.
To
Whereas
reduce.
in existing RDBMS, only the storage will be happening. Whereas in Hadoop, storage slash processing, both will be happening in that, right?
Correct. Correct.
Okay.
So if I have this one, so this question is, if I have like this, I can save 2 minutes of time. No,
Yeah, right. You are
that's what
right.
I'm trying to say. And also, so
Okay.
that is the reason it's time consuming process. Why it is time consuming process? There is no parallel process. It's a sequential process in existing system, and there is no data
Okay.
locality, guys. There's
Okay.
no data locality. So we have seen in existing system code locality. Wherever the code is there, your data is coming to there. There is another thing called data locality. Wherever the data is there, our code will go there. Our logic will go there. That's called data locality. If you have a data locality, you'll save a lot of time. It's a very simple example. Yesterday I was giving the same example to Manoj and Srinivas. So you guys are attending from online, right? You have saved a lot of time. You no need to travel. You no need to come to the class. You no need to wait for me, and you no need to no go back to
Yeah.
this traffic. We are sitting at home only. We are just having a conversation, right?
Yeah.
So you are not moving from your place. You are at your place only. The service is coming to you. That's called student locality. I mean, wherever the data is there, I will go and process there only. That's called data locality. So this is what I'm trying to explain here. So my logic, what are the logic I have written? That logic I'll pass to data. This logic, the logic I'll pass to data. There it will process, and I'll take the results. That's called data locality. And the fifth one is the most important. So if I want to get the parallel process, if I want to get the parallel process, I should have a distribution, right? Data should be distributed. See, if I want to do some parallel, if I want to some parallel work, let's say I was assume that I'm constructing a house. If only one person started constructing house, it will take so many days. If I distribute the work, hey, you do this part, you do this part, you do this part. Like if I distribute the work, the parallel process will happen, right? So to do that in existing
Yeah.
system, we do not have a data distribution. The data will be reside in the only one place, which is called data warehousing system. Correct?
Yes.
The sixth one is fault tolerant. No fault tolerant. It means let's assume that I'm processing the data. I have submitted my job of processing the data. This machine is crashed. This machine is crashed. So will my job will success or failure? Job will
Failure.
fail. So if I have a same data in other machine, if I have a same data in another machine, as soon as a request comes here, the server is not responding. The request is redirected to here. The
Hmm.
job will success or not?
Yeah. It will be getting success.
That is called fault tolerant. If the data is not available in the original copy, you go to the duplicate copy. That's called fault tolerant. We are tolerating the faults. So if fault happen also, no problem. I can still get you the results, right? So to get the fault tolerant, what I should have? Data should be duplicated.
Right.
No data replication in an existing system. These are the limits, guys. These are the limitations with an existing system. Is everyone clear about the limitations with an existing system? If you understand what is the
Yeah.
problems with an existing system, it's easy to understand how Hadoop solves those problems. Is this clear to everyone?
Yes.
Yeah. So who causes this problem? Before the system was working fine, all of a sudden I'm showing you these many limitations. Who caused that problem? Who is the reason? Why all of a sudden I started seeing these problems? What is the cause of the problem?
Amount of data that
Exactly.
needs to be processed.
Data. Can I say it's a big data?
Yep.
So what is a big data? What is a big data? Manoj or Mayank?
Yeah, data we will be able to, the huge volume of the data will be the big data, and the big data will be it's unstructured or semi-structured. The source can be anything.
Very good, very good.
The
Yeah. So I can say huge amount of the data
okay, yeah,
which cannot able to process and store efficiently using traditional system. Sorry, using traditional system. So let me put in a very simple way. There is a data. That data is not able to process or store efficiently an existing system. That data for that system is a big data. Let's say I have a 10 GB data. I have a 10 GB data. The 10 GB data is not able to process by using RDBMS. For RDBMS, 10 GB is a big data. For RDBMS, 10 GB is a big data. So let's say I have an email application. Email application. I cannot send 100 MB as a attachment. 100 MB is a big data for
yeah,
this email application. Correct?
mm, yes,
Right? So the data which has a special characteristics, which, I mean, whatever the reason, the system not able to process it. Whatever the reason, it can be a variety of data, it can be, I mean, volume of the data, it can be veracity of the data, whatever it is, whatever it is. I'm not talking about the characteristics now. It will take so much of time to explain all these things. There are 6 P's are involved in that. 6 characteristics are there for the data. That's called volume, velocity, variety. Let me give you a very high level. There are 6 characteristics are there for the data. One is volume, so very much important. Velocity, how fast the data is coming. Variety, how many types of data, structure, semi-structure, unstructured. Variability, variability means today I'm getting the structured data, all of a sudden it changed to unstructured. So variable, it keep changing. Veracity, veracity, how good the data is, how accurate the data is. Can I trust the data or not? Value. These are the most important characteristics of the big data. But you might have seen these three, most of the cases. Most of the world blogs, most of the world books will say that only these three V, but there are some other as well. So IBM says that there are 10 Vs. I really not sure what are other 4 Vs, but I saw only 6 Vs. I understand these 6 Vs. I have personally saw these 6 Vs. Okay, these are the characteristics. We'll talk about each and every characteristics in detail later point of time. Really not required at this time. Okay, so whichever the data is not able to process by an existing system in a given point of time, That data we can call as a big data. It can be whatever the reason. It can be volume of the data. It can be velocity of the data. It can be variety of the data. It can be whatever the reason behind it. Okay, that data we'll call as a big data. Is this clear to everyone?
Yes.
Yeah.
Okay, so how to solve these limitations? How to solve these limitations? Let's look at here. There is something called Hadoop. What is Hadoop? Hadoop. Hadoop. What is this? Hadoop is a Java-based. Hadoop is a Java-based framework. Hadoop is a Java-based framework which will store huge amount of the data and which will process the same amount of the data in efficient manner in the parallel process in a parallel link. Hadoop is a Java-based framework which will store the data efficiently and which will process the data efficiently in the parallel in a parallel fashion, I can say. So how it is? So Ravi, you're telling that it will store the data and it will process the data. How it will be? Is it a database? No, it is not a database. So to do that, how do you come up with the two different components? One is HDFS, other one is MapReduce. One is a HDFS, other one is MapReduce. HDFS stands for Hadoop Distributed File System. MapReduce stands for Map and Reduce. We'll talk about that later. Really not important at this point of time. Your MapReduce is for processing the data, and your HDFS is for the storage. It is for storage. It is for process. Sir, you are telling it is a storage, but you are telling it's a file system. So file system is what is a file system? What is a file system? Can anyone tell me?
Basically, a location where the data will be stored.
Location. Yep. A
File
layer.
system is a server.
Yeah, file system is a layer who actually manages the data. I mean, the files and folders where they have stored, right?
Right.
The file system is a man who manage is a virtual layer who manages your files and folders and who actually keep track of where the files and folders are stored, right? Actually, the data will store in the hard disk. The data will be
Mm-hmm.
stored in the hard disk in the form of small blocks, small chunks. Those chunks will be maintained by your file system, right?
Okay,
That
basically, it's a reference to those
yes,
areas.
yes, reference to
Okay.
those blocks, correct,
Locations, basically. Yeah. Okay.
right? So this file system will be used by operating system. Your operating system will make use of this file system, correct? Who actually uses the file system? Operating system only, no one else. You cannot see the file system. You may hearing
Mm-hmm.
about the what you called NTFS, ext4, and fat file system, fat file system. Like that, we will be hearing what type of file system is, but we cannot see that physically. We cannot see that. That's a logical layer. But who actually
Mm-hmm.
uses your operating system will use that file system, right? So
Right.
Hadoop come up with a different kind of file system. Okay, so why should I go with a different kind of file system? That we need to understand first. And I mean, what is the limitations of the existing file system? Then why should I go with a special file system? So I'll take quickly another 15, I mean, to 10 to 15 minutes of time. Is it fine with you guys?
Yeah.
Okay, good.
Yeah, sure, sure.
So let's try to understand the file system. Okay, let's try to understand the file system. First, as I told you, the file system is a virtual layer on top of your hard disk, or I can say the storage which you are storing. I think I'm drawing something here. Please try to recolor it if you remember anything about this. What is this? Do you guys seen any time before in your studies? I mean, in the when you are a student or something. Did you guys get a chance to understand this? I mean, understand in the sense, anytime you guys have seen anytime this one. So this is your hard disk. Do you guys get a chance to anytime look at this?
Yeah.
So in a hard disk, we'll be having magnetic tapes. I can call them as a. So do you guys the old music system? What you call xylophone? No, no, what is it called? I forgot the name of it. Old music system. What is that? I
We'll
forgot the name.
say as that record player, right?
Yeah, this kind of thing. Yes, these are the gramophone. I think some they'll call. I forgot the name of it. This one. Do you guys remember this one anytime? Or this one? Disc. This type of disc.
Yeah, it's called a record.
It's a record, right? So
Mm-hmm.
this is the record where it stores the
Yeah.
data, right? And you will be having a head who actually reads
Yeah.
and writes the songs.
Okay.
Read and write, right?
Yeah.
Right? Your hard disk also will be look like that. Your hard disk also will be looks like that. So your hard disk also has the circles and the straight lines. The circles will call tracks. We'll call them as the tracks, and we'll call them these guys as the sectors. Okay, let's assume that I have 1 GB file of data. Let's take a 100 MB file, not even bigger file. Let's take 100 MB file, and when I want to put this file into hard disk, let's try to understand what will happen internally. This file will be break into pieces. First, this file will be break into pieces physically, guys. It's a physical breaks. It's a physical pieces, I can say. It will break into pieces that each piece size is 4 KB. In the Linux file system, each piece size is 4 KB. That pieces will store in these machines. The pieces will store here in between two sectors tracks. The pieces will store here. The pieces will store in the sequence, guys. Sequence in the sense they will be having a sequence numbers. Each piece will have numbers, but they can store anywhere based on their head movement. They can store anywhere. It doesn't mean that they always store the sequence. They will be having a sequence numbers, but they will not store. The sequence numbers are like 1, 2, 3, 4, 5, like that. They will be having sequence numbers. They will store here and there. Now, the storage part will call as a block. Actually, we are getting into old days, or school days, or college days. This will call as a block. Okay, the data will store like this. Then your file system, no, your file system, as I told you, virtual layer, the file system will keep reference of them. Oh, file 100 MB file, let's say the file 1, F1. This F1 has the references.
இருக்கு.
You keep the references of all of them. You may have a file 2, you may have so many things. This file system will be managed by your operating system.
Veera, can you come again this point alone? The operating system you are talking about, you have drawn this, this one. What you are saying it?
File system. File system
Yeah,
layer.
okay.
File system layer who actually keep track of
Hmm.
the now
Hmm.
this 100 MB file is, let's say that it's a file 1, okay? File 1.txt. This file
Okay.
1.txt has been broken into pieces, right? Those pieces are loaded here and there in the hard disk.
Yeah.
Suppose
Yeah. In blocks, it has been stored in blocks.
yeah, suppose if you want to retrieve that file, I need to get the locations from the hard disk, right?
Yeah.
That location will be managed by your file system.
Okay. Okay.
Understand?
Yeah. Got it.
So the file system is the who manages your files and folders in the how it is stored, where it is stored. That information managed by your file system. Okay. Already have a file system. Then why should I go with the Hadoop file system? Already we have a file systems in the market, right? And why should I go with the Hadoop file
Mm.
system? Why? What is the reason behind it? So let me put in this way, guys, here. So the storage part, what I told you, the block size is, the block size is 4 KB, right? 4 KB only, right?
Mm-hmm.
100 MB
Yeah,
into 100 MB. If I want to convert into KBs, how many KBs will come? Right? Like this only.
20.
100 MB to
Content.
256. It means I will get the 25,600 blocks. Is this correct?
Mm-hmm.
So it means every my head, if I want to read this file, if I want to write this file into this, my head has to rotate how many times?
56,000 times.
So to put a small piece of data into file system, I need to move my head 25,600, I mean 25,600 times I need to move ahead. It means each time it retrieves, I mean, suppose if I want to read the same data, I need to seek, we'll call as a seeking. We'll call as a seeking. Seeking means who actually brings one piece of the data, one block of the data for each retrieval of each piece of the data. That's called seeking, data seek. So suppose if I want to access this 100 MB file, if I want to transfer this data from this hard disk to my pen drive, my head will move those many seeks, and my data transfer rate is always, my data transfer rate is 100 Mbps. My data transfer rate is 100 Mbps, and I have a very big channel, but my piece, my seek is send me 4 KB only, but I have a bandwidth of 100 MB. I have a bandwidth of 100 MB. I'm not making use of that much. I'm only sending 4 KB. Yes or no?
Yes.
Let's assume that this is my bucket, this is my tunnel. I have the huge capacity of the tunnel to pass a water, but I'm passing very less amount of the water, like small drops. If I pass a huge flow of water, I can fill my bucket very fast, right?
Right.
So in existing system, we're not making use of the whole 100 MB PS bandwidth of data transfer rate. So that is one of the limit. That's one of the limitation. The first limitation is the block size is very small and the data transfer rate is huge. To process the small amount of the data also, we're taking so much of time. Understand the first limitation of the file system?
Yes.
Veera, you are saying the block size is small in the sense the block size can be only 4 KB, or it can be extended, because the block size we are deciding it, right?
Where we are
It's not
deciding?
like that.
Where we are deciding?
No, no, 4 KB is the standard rate. Whatever the MB of file is there, it will be allocated as into 4 KB of file. It will be
Correct.
storing as 4 KB of. Okay, okay, yeah.
That is a fixed in your file system. It is not Hadoop. I'm not talking about Hadoop. I'm talking about the normal file system.
Okay, okay, yeah.
You cannot change the 4 KB. You don't have any control to change it. That's another limitation.
Oh, okay.
The first limitation is time. For even small data also, it will take so much of time. The second limitation is no control. And third limitation is I do not have a, suppose I'm saving a file into my hard disk in the C drive. I don't have option to copy three copies into three different machines or three copies into three different disks or three different folders. No replication automatically. Correct? I need to copy manually. These days,
Yeah, one question, Veera. Veera, one question actually. If I am using a system, say for example, I am using Core i3 processor and I am copying a file, I am copying a movie of 400 MB
mm,
from my pen drive to I am copying to my hard disk. Okay, say for in D folder.
mm,
Uh, it is taking for example, it's it's taking 40 seconds, I3 processor. Is there, if i7 machine, it will take the same 40 seconds for i7 processor, or it will take something later, the time will be lesser?
See, it will take same amount of the time. The processor comes into
Oh,
picture
it's
when you're doing a multiple processes. So
okay, okay, okay,
the
okay.
processor meant for the cores. Each core will process. Each core will have two processes. Each core can process two processes
Mm.
parallelly.
Okay.
So when you have suppose if you say i7 means you will be having I think some Intel i3 i7, right? I think it's a 5 core,
Mm. Okay.
not 7 cores will not come in that. I think 4 or 8 cores will come in your machine. So it means parallelly
Mm.
those many processes you can do. It doesn't mean that if you have i7, I dual core was taking 10 minutes of time. Your i7 will not take. It
Mm.
doesn't mean that it will take in a fraction of seconds. You can do multiple processes.
Okay.
You can play game parallel. You can play a video. You can do a parallel things. Multiple processes you can do it.
Oh, no, it won't copy it quickly. I thought the i3 processor will take, for example, i3 is taking 40 seconds, i7 will be copying within 10 seconds. It's
No,
not like that, right?
no, no.
Okay. Okay. Okay.
Okay. So I don't have a duplication
Yeah.
here. No duplication. Manual duplication. So these are the limitations. There are so many things if I keep on no, executing. So there are some limitations with the file system. So everyone agree with that, with respect to performance, with respect to control, and we have some limitation in the file system. Is that clear?
Mm.
That is
Yeah.
about the file system. This is about the file system. Okay. The next one is the distributed file system. What is the meaning of the distributed file system? So the actual meaning of the distributed file system, we already have a distributed file system in the in the market. We can say the network file system. Network file system. What is the distributed file system? So we'll be having a multiple machines are connected to one server in the network. We'll be having a couple of systems. Let's say I'm taking only 3 systems here, and all these machines will be connected to one layer, and we will be having one client here, client or whoever it is who actually take care of this. So these all machines are connected to this. Suppose if I don't have a distributed file system, if I don't have a normal network file system, if I have a normal file system, let's say I have 3 machines here. Machine 1, machine 2, machine 3. I have 3 machines and I'm a client. Okay, I'm a client machine. So now I want to process the data which is there in the machine 1. I have to log into this machine. I have to submit my job. I have to all things. I need to pass authentication, user authentication, authorization, right? I need to do all of them. After finishing the task, I can go to this machine. I can log into this machine, submit a job, and do all those things. And if I want to process this data, same. I need to log into this machine. I need to do that individually. I need to do that. Yes or no?
Yeah.
So if I have a network file system, let's say this is one machine where I have stored all employee data, and this is another machine where I have stored all student data. This is a machine where I have stored all software related data. Or something else, like say if you take any company, any organization, this is India data, this is Japan, this is US, and my client wants to process India data. So if in this case he has to manually log into India data, he has to process it. So many things are there. Again, he has to log in manually to this other country. He has to log in manually to other country. It means that he has to individually log into different machines. Correct? Where he's not able to see all the
Yes.
data one place. He's not seeing all the data into single place. He's every time he's logging into one place. Correct? But if I go with the
Mm.
network file system, what the network file system is doing, it's giving a flexibility. They're all connected to one server, right? They're all connected to network. They can easily. Where is the cursor? 1 second, guys. Okay, my cursor is that side. Okay, so my client no need to log into each machine individually. He just connect to the server, and he can see all India data here, the same machine. It looks like that. All Japan data I can see here. All US data I can see here. What are the data I want to fetch? I can fetch easily. So whatever the data I want to process, I can easily go ahead and process it. Whatever the data I want to process, I can go ahead and easily process it. I really no need to log in 3 different machines 3 times. So log in only one place, you can go ahead and do that. So do you guys remember your shared drives in our office? Shared drives.
Mm-hmm.
When you log into your shared drive, let's assume that sometimes we'll be having slash temp. Some locations they will give some location for you, right? When you look into this shared location, you are able to see that so many people started sharing the data. Everyone shared data you can see there, correct? In your
Right.
office, you have a ABCD, 4 employees are there. Your ex-employee, and when you log into this machine, you can see an employee which is shared by A. You can see an employee which is shared by B. C and D also you can able to see, but you can access only one. Let's say you have authorization to access only employee A, you can access only that, but you can see all the data, correct, right?
Mm-hmm.
I mean, is that correct or not?
Yes.
You may not be having a permissions to copy, you may not have the permissions to delete or something. You may not have a permission to open also sometime, but you can able to see
Vira,
it. Yeah.
Vira, sorry, Vira. Actually, due to some interrupt connection, I have lost connection just now. Reconnected. You are saying about the share drive in our office. Till that I was aware. After that, what you have said?
Yeah, how our shared drives work in the office, that's what I'm trying to say.
Okay, okay.
in, in
We will be having all the data, whatever the data we need to share from the, we can't, because we can't store all the data in our machine, so we are going for share drive.
Not exactly. Suppose if I want to give some my data to
Okay.
I want to share some data to my colleague. So pen drive is
Mm.
not allowed or something is not allowed, what we will do, we'll keep in the share on shared location. We'll give a permissions to him,
Mm.
read, write and
Well,
execute permissions, and he can copy to his local machine, correct?
yes, yeah, right. You are
And
right.
so when I put into
Yes.
the shared drive, you have shared with Mayank. Let's assume that I am also working in the same company. So then I also logged into the
Okay.
shared drive. Can I able to see that data I have shared?
Yeah.
I can
If you
see it.
are in the share drive,
I can able to see that, but I cannot able to
access
copy
it.
or I cannot able to access it. Correct? But
Yeah.
like that, there will be 100 employees who are all shared. A person being who has access to that shared drive, everyone can see that. But whoever has a permission to copy a data, that data only they can copy.
Hmm.
Correct, Mayank?
Yes.
Yeah. Right.
So, but we can see everyone's data, right? That's
Right.
where that is how the distributed file system works. So the distributed file system works. All the data looks like in single location. But is it really single hard disk or multiple hard disks? When
Multiple, but it looks like single.
yes, but when Manoj is shared the data is really not moved. He's moved the
Mm-hmm.
data. The data is still in his hard
No.
disk only. Correct? Still in his.
Right.
But since we are using the network file system, when I log into some of the location like this slash temp or slash share, I'm able to see the data which is there in his hard disk. Correct?
Right.
So, but when I look into that shared drive, for me it looks like a single hard disk or multiple hard disks.
It will look like single.
Single hard disk. That is called distributed file system. The data will be
Oh,
distributed to multiple machines, but it looks like it is available in a single hard disk. That is called distributed file system. The old distributed file system is network file system, which was introduced by Microsoft. This NFS network file system is from the Microsoft. Is that clear?
mm-hmm. Yes.
Okay. Sir, already I have a distributed file system. No. Then what is use of taking Hadoop distributed file system? So do you guys see the limitation here? The same limitation, 4 KB, time consuming and everything. And also data is residing. Let's say my India data, whole India data is there in single machine, correct? Whole India
Right.
data is in single machine. Suppose when I'm processing the whole India data, When I'm processing this data, if this machine goes down, I don't have a backup. I mean, backup in the sense I don't have a fault tolerant. I don't have a duplicate copy. By default, there is no replication. Again, all the limitations will come into picture. Yes or no?
Mm. Yes.
So that's the reason Hadoop come up with some different kind of file system, which is called HDFS. How HDFS works? HDFS also a distributed file system. We need to understand that. To create a distributed file system, we need a two type of machines here. Two type of machines.
And Veera, you are saying NFS currently, NFS provided by some Microsoft doesn't have the fault tolerant, doesn't have duplications,
Yes.
replications, right?
Yes. Yes.
Whereas HDFS it does, right?
Correct.
Okay.
Correct. So HDFS
One, my question is only one question. Why then Microsoft can be thinking of that and they can implement it is in NFS itself, right? Instead of going for HDFS, if whether it is possible to what are the limitations there, whether they can overcome in NFS itself, it's possible.
yeah, that's the reason they didn't think at the time of that. When Hadoop comes, they realized, oh, these are the things. That's the reason your Microsoft also come up with their own Hadoop. You
Okay, okay.
might have heard about the Azure cloud
Sorry,
Azure.
no, I am not sure. Sorry.
Okay, there is something called AWR Azure. It's a cloud services from
Okay,
it's a cloud service from Microsoft. In this cloud service, you have something called Hadoop, which is called HD Insights.
okay, okay,
Okay, they have their own Hadoop. Okay,
okay.
this Hadoop distributed file
Hmm.
system. To create this file system, we needed two type of machines. Two type of machines. It doesn't mean there are only two machines. Two types. One is a master type. The master type machine will call as a name node, and there are some other. This is master. Let me write here. MASTR master. And I'll be having some type of machines which are called slave type. Slaves. Please try to concentrate from here a little more, because here actually we are going to see how to solve the limitations of all the limitations whatever we have seen so far. So I want you to be little cautious, little more concept. Okay. Here we need a two type of machines. One is a master type, other one is slave type. The master type will call as a name node. The slave type will call as a data node. Data node. Okay. This data node is always connected to the master. Always connected to the master. He has to connect to the master. Your slave type machines always connected to the master. They always reported to the master. The slave type is always connected to the master, and he always send the status. That's called heartbeat. We'll call it a RPC protocol. It uses the RPC protocol to send a message, and every 3 seconds it will send a message. Every 3 seconds it will send a message. If a data node, a slaves fail to send a report 10 seconds, it means continuously 3 times, that slave might be failed, might be out of network. Your master thinks that it might be failed or out of network. Okay, so it is like our team, guys. Let me put in the real time. It's like our team. We'll be having a team manager and team members, and the team members has to continuously send the report to the team manager. If a team member didn't send the report to a team manager, it can be work report, it can be his availability, whatever it is. If a manager didn't get the update from the team member continuously 3 times, it means your manager thinks that either that guy is in out of office or in a leave, or he might have absconded. So your manager will not assign any work to you, because since he will not aware of whether you are available or not. Yes or no?
Mm-hmm. Yes.
Correct, right? If a team member
Right.
is not available continuously 3 days, he's not send any update, he not send any information, will you assign a work to him?
Mm-hmm.
You will
No.
not. We don't know when he will come back, because we don't have any update from him. Correct? Here also,
Right.
if a data node didn't send the heartbeat, we'll call a heartbeat. Okay, a signal. If a data node didn't send a signal continuously 3 times, your name node treat, name node treats that machine failed. I mean, failed in the sense either failed or either out of network. It will not consider that mission for the further processes or further storage. Okay. So this is the master slave architecture. The master will be only receiving the heartbeat information. Master will be only manages the slaves. You're like your manager. Our manager will be only manage the team. Will he do a development work?
No.
Will he do a testing work? No, no,
Mm-hmm.
actually. Okay. But there are some managers. I'm not talking about all the managers. I'm talking about only few managers. Those few managers will not really, they are meant for the managing the team. They're not really meant for the development. Correct? Development or testing. They're not really meant for that. They're meant for the different purpose. Correct?
Mm-hmm.
I mean, am I correct or not?
Not getting this
Yeah, you are
point.
right.
There are managers. Managers are not actually meant for the doer development work or testing work. The managers are meant for
Okay.
the managing the team. Yes or no?
Mm-hmm. Right.
Yeah, that's what I'm trying to say. Here, your manager is like a master. He is your manager, and
Mm-hmm.
these are team members. Okay. So whenever you store a data, okay, you will be having something called a gateway node, guys. Here, there will be one central node or a gateway node. Will not be having access to directly to the cluster, Hadoop cluster. This name node and data nodes together will call as a Hadoop cluster, who actually has the Hadoop software, right? This is we'll call as a client machine, or you can call as a gateway, or you can call as a edge node. Edge node. Okay, all three are same mission only. Okay, now look at here. I want to put a 1 GB file here. The file name is F1. Okay, Hadoop come up with some default properties. We need to understand them. Hadoop come up with the default properties. The block, we were talking about a block size, right? The block is 128 MB. In the Hadoop 2, I'm talking about Hadoop 2. In the Hadoop 1, it is a 64 MB. And there is something called automatic replication. Replication, which is 3. Okay, these are the major properties we need to understand. There are so many properties. You can go ahead and change also. It's not always fixed. By default, they are. You can go ahead and change. Now, this 1 GB file I want to put into Hadoop. I want to store into Hadoop. Look at guys how it will store. When I send a request to, when I send a request to, one sec, where is my cursor? Yeah, here. When I send a request to load this 1 GB file into Hadoop, what your client will do? First, your client will break the file. This is a common functionality in the file system, right? Breaking the file into
Mm-hmm.
pieces.
And Veera, in HDFS, the default block size will is 128 KB, whereas in normal file
MB,
system it is 4
MB,
KB,
MB,
right?
MB, MB, 128.
128 MB. Okay. Whether that can be changeable,
That
that
can be
is a
changeable.
user defined or it is
By
okay.
default, 128 MB, it can be changeable.
Okay.
Okay. So as soon as I send a request for the copy to HDFS, okay, your client will break a file into pieces. Your client will break the file into pieces. The pieces means the blocks. Block 1, block 2, block 3, and so on, block 8. Okay. Then your client will talk to a manager saying that, hey, I got some work which need to be stored in your cluster. The block size is this 128 MB. The replication factor is 3. That information is tell to a name node. The name node will check whether the user who has to done this. Some user only, no, like us only we have to do that operation, right? The user is authorized to do that. First it will check, yes, he is authorized, and the next point it will check whether the data is already exist in the Hadoop, the same path. If you are copying the data, you are copying the data from one path to another path, right? Let's say you're copying the data from the C drive, movies, okay, into movie name is Bahubali, let's say Bahu, okay, and you are copying the same data into D drive, into movies or whatever it is. The Bahu is already available. Will it copy? It will ask you immediately, do you want to replace or you want to overwrite? Correct?
Yes.
So in the Hadoop also, if the data is already available in the same path with the same name, it's already available, the data will not be copied. The data will not be copied. It will says that data is already available. Okay, with the same file name, same
Oh,
path.
we can't overwrite also. It's still, if it's there, if we try to overwrite.
We have a feature called to override, that we need to say that while copying, in the copy operation we have to say
Okay.
F, forcefully we need to
Oh,
do that.
forcefully copying.
Yeah, that we can do that. That I will talk later. Okay, that comes under command. Okay, I'm not bringing that into here.
Okay.
So if the it just validate whether the path is already available or not, whether the user is valid user to store or not. That will be validate. Who will validate? Your name node will validate. Once the validation is success, it will tell to the client saying that okay, you can copy. Then he will come up with a block one. Look at, guys, this is the most important part here to understand. That's called metadata information, which we are going to see. The file one is the request, right? Request came for the file one and come with the block one. First, it will take the block one, guys. Your client will take the block one first. Your client will take the block one. Let me take a different color. The client will take the block one, and the client will take the block one. The block one will go to the name node, and name node has to select how many machines? 3 machines. 3 different copies, no duplications. Yes or no?
Yes.
Your manager select 3 people. Your name node will select 3 people. 1, 3, 5. Let's assume that. Mission 1, mission 3, mission 5 it is selected. Okay. You may have so many other missions also. Okay. He has selected 3 missions randomly. How he selected, we'll talk about that later. There are some policies for that. He selected 3 missions. Now, your client, what he will do now? First, he will connect to here. First mission, nearest mission, which is 1 is the nearest. Next, he will connect to the third mission. He'll create a pipeline, guys. He'll create a pipeline to send the data. And third to fifth mission. This is a try to understand, guys. I'm repeating one more time. Your client will request to the name node for the block one. For the block one, not whole file, one block. It will take a one block first, not for the whole file, one block. Then it will go and tell to the name node, hey, I have a piece of data which has to store in 3 missions. Give me 3 mission IP addresses. So your name node will give 3 mission IP addresses. 3 mission IP addresses. Then your client will talk to those missions. Then your client will connect to those missions to transfer the data. Mission 1 and mission 1 will connect to the mission 3. Mission 3 will connect to the mission 5. Your client will connect to only one mission. Okay, your client will connect to only one mission. Internally, the missions all will connect to each other. Then the data will be start transferring. Then the data will be start transferring the packet by packet by packet, packet by packet, packet by packet. Once the data comes here successfully, the piece first packet, the same packet will be sent here. If it is receives the packet, then the same packet will be received sent here. Now, once this guy receives the packet, he will say that hey, I have received. I have received. He will send acknowledgement. He will send acknowledgement. Then he will also send acknowledgement here. Sorry. He will also send acknowledgement here. Hey, I have received it. And he will also say the same acknowledgement to the client. Hey, we already saved, and you send me the next packet. Like that, the data will be complete block, 128 MB block completely. They will send one packet by packet by packet by. Once the data node is stored successfully, the whole block, he will tell to the name node saying that, hey, I received the block. Then the block one, it will make a mark. Block one is stored in the mission 1, mission 3, mission 5. Next block 2, it will repeat the same process with the block 2. Block 2 can be stored in a second mission, third mission, sixth mission. Block 3, it can store in a 1, 2, 3. It means a single file has been broken into pieces. The single file is stored in the completely different missions. Do you guys observe the difference between other files and here?
Mm-hmm.
The data is not
But what if Yeah, but what if like in middle of that some machine stops responding?
Okay, the failure part will take care later. I understand. So suppose when I'm moving from data node 1 to data node 3 is not
Mhm.
responding. That's what you're trying to say, right? So
Right.
there is something called replication factor 3, right? And in the same configuration, there is something called minimum replication factor. Minimum replication factor. So that is by default 1. It means if I store at least one copy, my job is served. Okay.
Okay.
So it will take care of that. If my minimum replication factor also 3, if I'm not able to, it means I need to minimum 3 copies I need to store. If I'm lesser than that, my job will fail. Okay. But by default, the minimum replication is 1. Okay.
Okay.
So the
Mm-hmm.
failure scenario I detail explain in the regular class. So it's as part of the demo.
Veera, minimum replication should be two, right? In the demonstration, what we have 2 days before, you said giving
Replication factor
example that
3.
you are,
Replication factor is 3. That is not minimum.
no, the minimum replication factor you are saying it's one. We can keep it as also one. You said, right?
No, I think you somewhere we missed, Manoj. The default replication factor is 3. Okay. By default, 3
Okay, okay,
copies.
okay,
By default, 3 copies.
okay,
No doubt in that. And there is something called minimum
okay,
replication factor. There is one more maximum
okay,
replication factor. Maximum is
okay.
5.
What is the difference between minimum replication, maximum replication, those things?
That's what I'm trying to say. So while
Mm.
I'm loading the call data, there may be a chance one or two missions go failed, right?
Mm-hmm.
If
Yeah.
it is fail, whether my job should be success or failure, decided by the minimum replication factor. If at least one copy is stored successfully, at least one copy,
Mm.
at least one
Mm.
copy is stored successfully, my
Mm.
job is success. Job will not fail.
Okay, okay,
But whatever the rest of the 2 copies, that will be there under replica, that will be taken care later.
okay,
So maximum, how many copies you can store? 512 maximum you can store. But those are also configurable. You can change the numbers. No problem at all. You can change the numbers.
okay.
Understand?
Yeah.
Now let's assume that my data is stored successfully. Okay, my data is stored successfully. One second, guys. My cursor will be disappeared sometimes. Yeah. So my data is stored successfully in all the machines. Okay. So when I store, I'll get the meta information like this. So let me put the meta information here clearly. File 1, that is divided into block 1, block 2, block 3, block 4, and so on. So the block 1 is stored into mission 1, mission 3, mission 5. Block 2 is stored second mission, fourth mission, sixth mission. Block 3 is stored in a 1, 3, 5. It can be possible, okay? Block 4 stored 1, 2, 3, and so on. This is the meta information. I need this information to retrieve back, right? This information managed by your manager, like how you Excel sheet manages. This guy Manoj has these tasks. He's doing this sprint. Mayank has these tasks. He's doing this sprint. So he will be maintaining Excel sheet, right? Similarly, your name node maintains the metadata information. Here, your name node is not stored data, correct? The actual data is not stored. Like our manager does not actually work on the development work. He's just managing the team. Yes or no?
Yes.
Here also, your master is not actually store the data, correct?
Okay.
Yes or no? Here also, your
Then who?
name. Go ahead, please.
Like I was confused. Like then who will store this data? Like if master is just managing, who will store the metadata?
He's storing only metadata. He's storing only metadata. He using metadata only. He's managing, right?
Okay. Okay.
Actual data he didn't store, right?
Right. 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 Only metadata master is storing.
Correct. Now look at
Yep.
guys here. So I'm going to solve the problems now. The very first one, time, cost. The first limitation is cost, right? Look at here. I am not using the very big servers here. I'm using the commodity hardware, cheaper hardware, very cheaper hardware, but multiple missions. But multiple missions. right? So
Right.
I really does not require the dedicated hardware, and it is open source. The software is open source. I no need to pay to anyone. The cost is reduced.
Mm-hmm.
Cost is reduced. So it will be available for the small scale and middle scale organizations who can go ahead and implement their own architecture, and give the who can go and give the solutions to analytics problems. Correct? Cost
Right.
is solved. Cost problem is solved. The next problem is time. Okay, look at guys here. Since the data is distributed across the multiple machines, now I want to process the file one. Now I want to process the file one. Okay, this is the file one, right? I want to process this file one. Let me take a different color, which is a green color. So now I want to process the file one. So my file is, since it is distributed across the multiple machines, I can parallelly process. My block one will be processed in machine one. My block two will be processed in fourth machine. My block three will be processed in the third machine. It can choose any randomly. My block 4 will be processed in the second machine, and my block 5, block 6 all will be processed in different machines parallelly. They're processing parallelly or not?
Yeah.
All blocks, all pieces will process parallelly. All pieces will be processed parallelly. It will take the results and club as a single result. It means I'm
Okay.
doing a parallel process. Actually, these small pieces are called map tasks, and this will call a reduced task. We'll talk more about later, guys. I really don't want to make you confused in the single demo. Okay, I have a parallel process. Since I have a parallel process, less time. Correct?
Mm-hmm.
And I have a question here, Veera.
Go ahead.
Can you scroll down? Scroll down. Scroll down to that blocks. Yeah, here F1 file 1 you said B1 B2 B3 B4, and B1 you said I am storing in first machine, third machine, fifth machine, B2 second machine, fourth machine. Because B1 data and B3 data are stored in the same machine 3. Okay,
Mm.
if the master node, if the master, the name node, how he will be identifying the data from the machine 3 is from B1 or the data from the machine 3 is B3?
So how
How
does it matter?
he
So you tell me, how does it matter? He'll be having a block information, right? The block ID. He has a block ID,
block
right?
ID? Okay.
Mission one, whether I'm taking a block ID, whether I'm taking a block one, he has the ID, right?
Yeah.
Yes or no?
Oh, yeah. Oh, 3. Oh, it will be showing B3 3 here, whereas it's B1 3. Okay, like that.
Yeah,
Okay.
got it.
Oh. Yeah, right.
Your data retrieval is parallel, but data insertion is not parallel processing, right? That's
Correct,
sequential.
correct. That is correct.
Okay.
Okay. Here I have a parallel process. Since I have a parallel process, I have less amount of the time, and the data is distributed. Yes or no?
Yes.
Properly distributed data, and
Mm-hmm.
data is also replicated. 3 copies by default. Correct.
Right.
Yeah.
And coming to data locality, look at guys this here. This also problem solved. So now wherever my data is there, I'm processing there only. My data is there mission 1, I'm processing mission 1. My data is there mission 4, processing mission 4. Mission here I'm processing there only. Yes or no? Data locality. I'm not moving the data. Am I moving the data? No.
Mm.
No.
So data locality is there, right? Let's assume that I'm processing the data in the mission 1. The mission 1 is crashed. My job will not fail. I have a data in the third mission. So my master smartly says that you go ahead and process in mission 3 or mission 5. Either of mission you choose. It's randomly. You go and process in the mission 5, it will get processed. I have a automatic fault tolerant. Yes or no?
Hmm.
Automatic fault tolerant. So these are the, this is how Hadoop process the data. This is how Hadoop stores the data. I hope you guys have might have understand the base and why Hadoop, why not HDFS, this information. Is this clear?
Yeah, right. Clear.
Okay, so that's it for today. It's already 9. I'm also getting late to my class, so we will see. I mean, he will get back to you. Our Gopi will get back
Hmm.
to you. 1 second.
Sure, sure, Veera.
Yeah,
Veera, you're back to Bangalore or
yeah,
still
back to
your
Bangalore.
native?
It's now
Okay.
7:15. I'm
How?
back to the Bangalore, and Gopi
Okay.
called me and said that about this demo.
It's the same thing for me also. Gopi yesterday informed I was traveling just now. Just 7:35 I reached Coimbatore, my
Oh,
native.
okay, okay, okay. Okay, I just reached Bangalore. I was in hometown, so my grandma was
Okay.
not well, so I just came here.
Oh, how is she now?
No, she's in final stage, so there is no
Okay.
something. Yeah.
Hmm. Okay.